A storm the size of an entire country just tore across the Pacific. And by the time it finished, meteorologists were calling it one of the most physically massive tropical cyclones anyone alive has ever tracked. We're talking about Super Typhoon Bavi, and the scientists watching it grow are warning that what just happened is only the beginning of a season nobody was fully prepared for. Let's start with just how enormous this storm actually became, because the raw numbers here genuinely defy normal comparison and reset what most people assume a single tropical cyclone is even capable of. At its peak, Bavi's overall footprint was roughly the size of France. One meteorologist covering the storm described it as nearly twice the physical size of a typical hurricane, an almost unimaginable scale for a single rotating weather system to reach. This wasn't just a strong storm. It was a storm so large it could blanket weather conditions across multiple countries simultaneously, all at once. Bavi didn't arrive out of nowhere either. It began as a disturbance southeast of Kwajalein in late June, quietly organizing over waters that were significantly warmer than average, paired with low vertical wind shear, essentially the perfect recipe for explosive intensification. Within days, both the Japan Meteorological Agency and the Joint Typhoon Warning Center had upgraded it into a full typhoon as it rapidly strengthened, eventually reaching Category 5 equivalent intensity with sustained winds estimated near 290 kilometers per hour. To put that number into perspective, that's a storm powerful enough to flatten poorly constructed buildings, snap power lines like twigs, and send debris flying with lethal force across entire neighborhoods in a matter of seconds. When Bavi's eyewall passed directly over the island of Rota in the northern Mariana Islands at peak strength, local officials reported major damage, a small preview of the destructive force this storm was carrying as it continued tracking northwest across the open ocean. From there, Bavi's path took it through the Philippine Sea, brushing past Taiwan and Japan's southern islands, bringing damaging winds and heavy rain to each in turn before setting its sights directly on mainland China. Along the way, the storm went through what meteorologists call an eyewall replacement cycle, a natural process where a storm's inner structure temporarily reorganizes, causing brief fluctuations in strength before the system often re-intensifies or begins a steadier weakening trend. By the time Bavi approached the Chinese coastline, forecasters had already issued an orange typhoon alert, the second highest tier on China's 4-level warning scale, a signal to residents and local officials alike that this was no ordinary approaching storm. Hundreds of flights were canceled. Rail services were reduced. Schools and ferry operations across affected provinces were suspended well ahead of landfall. Authorities ultimately evacuated nearly 2 million people across Zhejiang and neighboring regions, one of the largest coordinated evacuation efforts the country has carried out in recent memory. Bavi finally made landfall near Yuhuan in Zhejiang province late in the evening, followed shortly by a second landfall in the densely populated city of Yueqing, marking the storm's second direct strike on Chinese soil within the span of a single night. By that point, the storm had weakened considerably from its peak intensity, arriving as roughly the equivalent of a Category 1 hurricane. But here's the critical detail that made this storm so uniquely dangerous despite that weakening. Its sheer physical size meant it was still carrying enormous volumes of moisture in its outer rain bands, producing flooding and destructive winds across an area far larger than a typically sized storm of similar wind speed ever would. Residents along the coast described the storm surge and flooding in visceral terms. One correspondent reporting from the coastal city of Taizhou was nearly swept off her feet by a sudden storm surge as Bavi made landfall. Another resident in Yueqing described hearing roof tiles and tree branches falling throughout the night, while a walkway beside his residential compound simply vanished beneath rising floodwater. China issued its first red rainstorm alert of the entire year in response, its highest level warning specifically reserved for the most extreme rainfall threats. It's worth spending a moment on that first storm, Typhoon Maysak, because the two events together paint a much fuller picture than either does alone. Maysak made landfall on China's southernmost island province of Hainan before sweeping into the Guangxi region, where it caused the most significant damage of its track. Its remnants didn't simply dissipate quietly either. They went on to spawn at least 2 inland tornadoes across central China, an unusual and dangerous secondary hazard for a storm system that had technically already been downgraded from typhoon status by the time it reached that far inland. The floodwaters Maysak left behind were still actively affecting southern China when forecasters began tracking Bavi's rapid intensification out over the open Pacific, meaning emergency responders barely had a chance to shift from one crisis before the next. One was already bearing down on the coastline. That back-to-back sequencing is precisely what climate scientists mean when they talk about compounding disaster risk. A single major storm is disruptive enough on its own, but a region's ability to recover, repair infrastructure, and restock emergency resources depends heavily on having adequate time between events. When storms arrive in rapid succession, as Mesak and Bavi did within roughly a single week of each other, that recovery window shrinks dramatically, and the cumulative toll on communities, agriculture, and infrastructure becomes significantly harder to fully calculate using any single storm statistics in isolation. China's National Climate Center had actually forecast this kind of intensified activity before the season even ramped up, projecting as many as 6 typhoons forming across the Northwest Pacific and South China Sea during July alone, well above the historical average of roughly 3.8 storms for that same period. Forecasters also projected that up to 3 of those storms could make direct landfall, again, notably above the typical norm of under 2. Crucially, officials didn't just predict more storms, they specifically warned that the intensity of these cyclones would be stronger than usual as well. One climate scientist tracking the situation put it bluntly. The problem with these events, he explained, is that they simply keep increasing, both in frequency and in magnitude, without giving affected regions adequate time to recover and build genuine resilience between successive impacts. A warning that carries obvious weight given how quickly Bavi followed Mesak onto the same stretch of coastline. That observation captures the real concern here far better than any single storm's wind speed ever could. It isn't just that Bavi was unusually massive, it's that Bavi arrived as part of an accelerating pattern, one storm compounding the damage of the last before recovery efforts even had a chance to begin. So why is this happening now, specifically? The answer connects directly back to something increasingly familiar to anyone following ocean temperature trends this year. Bavi organized and intensified over waters running significantly warmer than typical seasonal averages, conditions tied to the same broader pattern of record-breaking ocean heat spreading across the Pacific this year, layered on top of an El Niño event that forecasters widely expect to strengthen considerably through the rest of 2026. Warmer ocean water acts as fuel for tropical cyclones, and it also allows warmer air to hold significantly more moisture, a combination meteorologists directly cited as contributing to both the storm's explosive intensification and its capacity to dump such extreme rainfall totals once it reached land. That combination, warmer water intensifying storms and warmer air loading them with more moisture, is exactly the kind of compounding mechanism scientists have been warning about for years as global temperatures continue climbing. And it's a mechanism that doesn't respect national borders or coastlines, striking wherever ocean heat and atmospheric conditions happen to align. It doesn't necessarily mean every single storm this season will match Bavi's extraordinary physical size, but it does mean the underlying conditions capable of producing storms like it, storms that grow unusually large, intensify unusually fast, and carry unusually dangerous volumes of rainfall, are becoming measurably more common as ocean heat content keeps climbing year after year. If you're finding this kind of detailed breakdown genuinely useful, go ahead and hit that like button. It makes a real difference getting content like this in front of more people, trying to understand what's actually driving these headlines, instead of just scrolling past another dramatic satellite photo without any real context behind it. Let's talk about what typically happens after a storm like this moves through, because the aftermath often proves just as dangerous as the storm itself. Regions forecast to receive between 300 and 500 millimeters of rainfall, with some areas seeing totals running 40 to 80% above their seasonal average, and a few spots potentially receiving more than double their normal rainfall, face serious risks of landslides, agricultural devastation, and prolonged flooding that can persist for days after the wind has died down completely, long after the storm itself has faded from headlines. Emergency shelters opened across Zhejiang province remained active well after Bavi's winds had subsided, as flooded farmland and damaged infrastructure continued posing hazards to returning residents. For those living in typhoon and hurricane-prone regions anywhere in the world, Bavi's story carries a genuinely important lesson that extends well beyond China's coastline. Storm intensity, measured purely by wind speed, doesn't always tell the full story of how dangerous a system really is. A weakening storm arriving at Category 1 strength can still produce catastrophic, widespread flooding if its overall physical footprint is large enough to drag. Extreme rainfall across hundreds of additional kilometers that a smaller, more typically sized storm would never reach. That's precisely why meteorologists increasingly urge people to pay attention to a storm's total size and moisture content, not just its peak category rating, when deciding how seriously to prepare for an approaching system. A downgraded storm heading toward your region is not automatically a safe storm, particularly if forecasters are specifically flagging it for its unusual physical scale. Emergency planners in coastal regions worldwide have begun incorporating this lesson directly into public messaging, shifting away from simple category-based warnings toward messaging that emphasizes total rainfall potential and storm surge risk alongside wind speed, precisely because storms like Bavi keep demonstrating how misleading a single category number can be on its own. At the end of the day, what happened with Bavi isn't really a story about one exceptionally large typhoon, remarkable as it genuinely was. It's a preview of the kind of storm season forecasters have been actively warning about, one shaped by record ocean heat, an intensifying El Niño, and atmospheric conditions increasingly capable of producing tropical cyclones that grow larger, strengthen faster. Some years. If the ocean conditions currently fueling storms like Bavi persist through the coming months, as forecasters increasingly expect given the strengthening El Niño pattern, there is a real possibility that this season's most significant systems have not yet even formed. That's precisely why meteorologists tracking this year's activity are urging coastal communities across the entire Northwest Pacific Basin to treat early season storms like Bavi and Maysak not as isolated headline events, but as an early warning sign of what an intensified back half of the season could realistically bring. Whether the rest of this Pacific typhoon season continues matching that intensified trajectory remains to be seen, but the early signals, 2 significant storms striking China within a single week, a forecast calling for well above average typhoon activity, and a storm the physical size of an entire country, all point in the same direction. This is shaping up to be a season that keeps testing exactly how prepared modern infrastructure and emergency systems really are, storm after storm, province after province, with very little time to fully exhale in between. If you want to keep tracking exactly how this storm season develops, along with the real science behind every major weather event before it becomes tomorrow's viral headline, subscribe to the channel so you don't miss the next update. Stay safe, stay prepared, and I'll see you in the next one, breaking down whatever the Pacific decides to send our way next.